Hello Year 10. I'm going to read through the assessment today. If you don't need a reader or you don't think it will help, you don't need to watch this video. You can just crack on with the assessment by yourself. But let's have a look. Make sure you download a copy and then click enable editing. It makes it easy for me if you send me back the actual Word document, because then I can mark it and send it back to you. So let's have a look then. Figure 1 shows 2 iron nails hanging from a bar magnet. So before I continue, I should say, I'm going to go through this quickly, so if you need to, you just pause the video and then do the question and then unpause it. K is the hotkey for pressing pause on the keyboard while you're on YouTube. So again, question 1. 2 iron nails hanging from a bar magnet. The iron nails which were unmagnetized are now magnetized. Complete the sentence. Use a word from the box. The iron nails have become blank magnets, and the 3 words are forced, induced, or permanent. Part B. Each of the 3 metal bars in figure 2 is either a bar magnet or a piece of unmagnetized iron. The forces that act between the bars when the different ends are placed close together are shown by the arrows. So let's have a look at figure 2. Bar 1, which has side B facing towards the middle, is attracted to bar 2, which has side C towards the middle. That's what this diagram means. So let's have a look. Bar 1 is attracted to bar 2, but this time bar 2 has been flipped, so side D faces the middle. But bar 1 is repelled by bar 3, and bar 3 has side E towards the middle. Which one of these metal bars is a piece of unmagnetized iron? Tick one box. Is it bar 1, bar 2, or bar 3? Then, give a reason for your answer. So you get 1 mark for the box, you get 1 mark for your reason. And make sure you refer back to the diagram. Part C. A student investigated the strength of different fridge magnets by putting small sheets of paper between each magnet and the fridge door. The student measured the maximum number of sheets of paper that each magnet was able to hold in place. Why was it important that each small sheet of paper had the same thickness? D. Before starting the investigation, the student wrote the following hypothesis. The bigger the area of the fridge magnet, the stronger the magnet will be. The student's results are given in the table below. So column 1 is fridge magnet. Column 2 is area of the magnet in millimeters squared, and column 3 is the number of sheets of paper held. So we've got fridge magnet A had an area of 40 millimeters squared and was able to hold 20 sheets of paper. Fridge magnet B had an area of 110 millimeters squared, but was only able to hold 16 sheets of paper, and so on. Give 1 reason why the results from the investigation do not support the student's hypothesis. And again, you just look at the results in the table and give 1 reason. Question 2. Figure 1 shows a magnet moving into a coil of wire. This movement causes a reading on the voltmeter. Use the correct word from the box to complete the sentence. The words are generated, induced, and produced. Moving the magnet into the coil of wire causes a reading on the voltmeter because a potential difference is blank across the ends of the wire. B. A student investigated how the number of turns on the coil of the wire affects the maximum voltmeter reading. The student changed the number of turns of coil on the wire, then moved the magnet into the coil. The student recorded the maximum voltmeter reading. to obtain valid data suggest two variables that the student should control in this investigation. Okay. Part C. The student's results are shown in figure 2. One of the results is anomalous. Suggest a reason for the anomalous result. Now you have to look at the graph in this case, and I'm talking about the labels on the axes. The maximum voltmeter reading in volts is on the y-axis, and the number of turns on the coil of the wire is on the x-axis. If you are not sure, I would do part 2, which is draw a line of best fit on figure 2. Now the best way to do that is if you look here, click the draw button, insert, click shapes, use a line here, so just a straight line, and put your straight line on the graph how you think the line of best fit will go. Then once you've done that, have a look at the graph. One of the results is anomalous. Suggest a reason. Now you have to be specific about this. Why do you think that reason was wrong? Part D. A data logger can automatically record and store data. It may have been better for the student to have used a data logger in his investigation rather than a voltmeter. Suggest one reason why. Now before I move on to the next question, please make sure you have drawn your line of best fit on that graph. Question 3. The left-hand rule can be used to identify the direction of the force acting on a current carrying conductor in a magnetic field. Part A. Use the words from the box to label figure 1. The words are current, field, force, potential difference. Now figure 1. You've got a diagram of a hand. Now you have to look at the orientation of this hand. I would get your hand and try and copy what that person is doing so you know which finger you are talking about. So this is your left hand. Now the top box, which is to this finger here, is the direction of blank. The middle box is for the middle finger here, which is the direction of blank. And the bottom box is for the thumb, the direction of blank. So you are remembering Fleming's left-hand rule, and you are labeling which each finger represents. Figure 2 shows an electric motor. Draw an arrow on figure 2 to show the direction of the force acting on wire AB. So here's A and here's B. Okay. And you can see the arrow for the current flow. You can see the north and the south poles of the magnet. So now you need to use your left-hand rule to figure out the direction of the force that this wire feels. Part 2. If you can't do part 1, that's fine, but part 2 is the theory behind it. So you should remember these ones. Part 2. Suggest 2 changes that would increase the force acting on the wire AB. And part 3. Suggest 2 changes that would reverse the direction of the force acting on the wire AB. Part C. A student used an electric motor to lift mass. This is shown in figure 3. There's your motor. Here's your mass. The student varied the electrical input power to the motor. For each different electrical input power, he recorded the time taken to lift the mass and calculated the output power of the motor. The results are shown in the table. So the first column is test. The second column is electrical input power in watts. The third column is work done lifting the mass in joules. The third column is time taken to lift the mass in seconds. And the fourth column is the output power in watts. So for example, let's look at A. Test A. The input power was 20 watts. The work done was 24 joules. The time taken to lift the mass was 2.4 seconds. And the output power in watts was 10 watts. So, calculate. I missed a line there. The result for test D is anomalous. Part 1. Calculate the efficiency of the motor in test D. And remember, well, you have to remember your efficiency equation. It is to do with input power and output power. Comment on your answer that you've just done to part C1. They've given you a hint. The result's anomalous. Comment on your answer. Part 3. Suggest a reason for this anomalous result. Now you have to say specifically what happened in this experiment to create that anomalous result. Question 4. The diagram shows a switch that is operated by an electromagnet. What is this type of switch called? Part 2. This type of switch is used in a car starter motor circuit. Explain how turning the ignition key makes a current flow in the starter motor. So there's the ignition key, there's the starter motor. Notice they are separate circuits. The explanation has been started for you when the ignition key is turned, and finish it off for 3 marks. Okay. Question 5. The diagram shows a USB power adapter which plugs into a 230 volt AC mains socket. The adapter contains a small step-down transformer. The core of the transformer is made of laminated soft iron. Part A. Why is iron used? Part B. The coils of the transformers are made of insulated copper wire. Why is the wire insulated? Part C. There are 500 turns on one coil of the transformer and 20,000 turns on the other coil. Use the equation in the box to calculate the potential difference across the secondary coil. And the equation reads potential difference across the primary divided by potential difference across the secondary equals number of turns on the primary divided by number of turns on the secondary. Show clearly how you work your answer out and give the unit. Just as a little hint there, if the question ever says give the unit, one of those marks is reserved for that unit. I'll give you another hint. You need to use the information at the start of the question. Okay. Question 6. Figure 1 shows a piece of apparatus called a current balance. When the switch is closed, the part of the wire labelled X experiences a force and moves downwards. What is the name of the effect that causes the wire X to move downwards? That was part A. Part B. Suggest one change you could make to the apparatus in figure 1 that would increase the size of the force that the wire X experiences. Part C. You've seen this question before, actually, now that I think about it. Hopefully you watched the lesson where I actually went through and marked it using my pen and showed you the working out. Part C. Figure 2 shows how a small weight placed on the insulating bar makes the wire X go back and balance in its original position. The wire X is 5 centimeters long and carries a current of 1.5 amps. The small weight causes a clockwise moment of 4.8 times 10 to the minus 4 Newton meters. Calculate the magnetic flux density where the wire X is positioned and give the unit. You are allowed the equation for this, but I would expect you to remember it. If you don't remember it, you can Google the magnetic flux density equation, GCSE. Make sure you give the unit, remember that is 1 mark. Question 7. In the national grid, very large step-up transformers link power stations to the transmission cables. A transformer used for this purpose has 800 turns on its primary coil and 12,800 turns on its secondary coil. The potential difference across its primary coil is 25,000 volts, or 25 kilovolts. Use the equation in the box to calculate the potential difference across the secondary coil. We've seen this equation before, so I won't read it out again. Show clearly how you work out your answer. Potential difference across the secondary coil equals blank volts. Notice the unit there. Part B. The diagram shows the structure of a transformer. The primary and secondary coils of a transformer are made of insulated wire. Why is this insulation necessary? Part 2. Why is the core made of iron? Part 3. Explain how the transformer works. 3 marks, 3 points. C. Before 1926, large towns had their own local power stations. After 1926, these power stations were connected to form the national grid. Give 2 advantages of having a national grid system. And think about this as more common sense answer than, well, it is a bit sciencey as well, but think more for the people and for the person controlling it. What are the advantages? Question 8. In this question, you will be assessed on using good English, organising information clearly, and using specialist terms where appropriate. Now, you are not assessed on spelling or grammar. When it says good English and organising information clearly, it just means putting it in a good order so it's understandable. So, there are 2 types of There are 2 types of traditional transformer: step up and step down. Describe the similarities and differences between a step up transformer and a step down transformer. You should include details of construction, including materials used, and the effect the transformer has on the input potential difference. You should not draw a diagram. Now this is 6 marks. And as a little hint, you should use what you have already seen in your paper. So go back and have a look at maybe some diagrams that are there. And that is the last question. So please finish it off, email me with your name on, and I'll mark it and send it back to you.